Atmospheric jellyfish, strange life forms living in Earth's upper clouds. We've always searched the stars for alien life. We've pointed telescopes toward Mars, Europa, distant exoplanets orbiting dim red suns. We've scanned radio frequencies for whispers from beyond the solar system. But what if something ancient is already drifting just miles above your head? Not spacecraft. Not weather balloons. Not classified aircraft. Something translucent. Something gelatinous. Something alive. The ghostly encounters of the stratosphere. In 2026, high-definition satellite imaging systems began detecting anomalies in the upper troposphere and lower stratosphere, between 10 and 18 kilometers above Earth's surface. At first, they appeared as distortions in cloud movement. Wisps separating from storm systems and reforming in impossible ways. Shapes elongating against 150 km/h jet stream currents. Cloud physics does not allow stable, coherent forms at that altitude for extended periods. Yet these shapes persisted. They rotated slowly. They pulsed faintly. And most unsettling of all, they moved against the wind. Meteorological analysts initially classified them as thermal anomalies, but thermal anomalies disperse. These did not. They maintained internal cohesion across multiple satellite passes. When infrared overlays were applied, faint energy signatures appeared, bioluminescent-like emissions in narrow spectral bands. They resembled the glow of deep-sea jellyfish. But this was not the ocean. This was the sky. Pilot testimonies from above the clouds. Long before satellites recorded these anomalies, pilots had been reporting them. Commercial airline captains described massive translucent shapes drifting above thunderheads at cruising altitude. Military pilots during high-altitude intercept drills logged visual contact with gelatinous masses that shimmered, then dissolved into vapor upon radar lock. One declassified testimony from a reconnaissance pilot detailed an encounter at 14 kilometers altitude. It looked like a floating cathedral made of glass. Veins of light ran through it. It wasn't solid, not like metal, but it wasn't vapor either. When we adjusted course toward it, it brightened, then simply faded. For decades, such reports were dismissed as optical illusions, sunlight refracting through ice crystals, fatigue-induced hallucinations, rare atmospheric plasma effects. But when 2026 satellite footage mirrored those descriptions almost exactly, dismissal became harder. Harnessing the ionosphere, the upper atmosphere, is not empty. It is electrified. Charged particles from the Sun collide with atmospheric gases, creating ionization layers, regions of subtle electrical energy constantly shifting above the planet. The ionosphere hums with invisible power. What if something evolved to feed on it? The atmospheric jellyfish hypothesis proposes a radical possibility: ultralight, semi-transparent organisms composed of thin, flexible membranes filled with lighter-than-air gases. These creatures would float at equilibrium within specific temperature and pressure bands. Instead of hunting prey, they would harvest energy from electrical gradients, absorbing ionospheric charge the way plants absorb sunlight. Bioluminescent pulses could be byproducts of this energy conversion. Their gelatinous structure would allow them to flex with wind currents while subtly adjusting buoyancy, rising and descending within narrow atmospheric layers. To ground observers, they would appear as shifting cloud formations. To radar, they would register weak, inconsistent returns. To pilots flying too close, they would seem to vanish, because their density barely exceeds the surrounding air. Moving against the jet stream, one of the strongest pieces of supporting data emerged from comparative motion analysis. In March 2026, a polar orbiting satellite tracked a translucent anomaly over the North Pacific for 43 minutes. The object maintained a slow northward drift despite powerful west to east jet stream flow. Clouds around it streamed rapidly east. The anomaly resisted. Wind shear modeling confirmed that passive vapor could not maintain such direction. Only active buoyancy control, or internal propulsion, could explain the deviation. But propulsion implies metabolism. And metabolism implies life. Historical roots of sky beasts, the concept of atmospheric organisms is not new. In the 18th century, early balloonists sketched strange shapes drifting above cloud layers, enormous translucent forms they described as sky medusae. In the early 1900s, meteorologists theorized about aerial plankton, microscopic life forms carried by air currents. That theory proved partially correct. Bacteria and spores do travel the skies. But macroorganisms? That remained fantasy. During the Cold War, several fast-mover sightings recorded by radar operators involved slow, drifting masses that accelerated briefly before fading. The data was archived under unidentified atmospheric phenomena. Today, with advanced hyperspectral imaging, those archived flight paths overlap with modern anomaly clusters. The pattern suggests recurrence. Migration. Perhaps even breeding cycles tied to seasonal atmospheric shifts. The biological frontier above us. If atmospheric jellyfish exist, they represent a new ecological layer, one entirely separate from land and sea. They would inhabit a narrow atmospheric corridor where temperature, pressure, and electrical activity align perfectly. They would be invisible from below, untouchable from above, drifting silently over cities, oceans, deserts, feeding on lightning-charged air, communicating through pulses of light and electromagnetic fluctuations. Perhaps they gather during storms, absorbing massive electrical surges. Perhaps thunderheads are not merely weather systems, but feeding grounds. The implications stretch beyond biology. They reshape our understanding of Earth as a layered ecosystem, not just vertically stacked terrain, but vertically stacked life. The radar paradox. Skeptics argue the anomalies are radar ghosts, interference caused by atmospheric moisture gradients. But radar ghosts do not emit consistent bioluminescent spectra. They do not maintain coherent shapes across optical and infrared sensors simultaneously. And they do not vanish precisely at the moment of direct approach. Several military radar logs note that upon locking onto these anomalies, signal strength drops abruptly, as if the target disperses or alters density intentionally. Coincidence? Or adaptive camouflage? The silence above the most unsettling aspect of the atmospheric jellyfish hypothesis is not their existence. It is their proximity. They would not dwell millions of miles away. They would float within reach of commercial aircraft. Within reach of mountaintops. Within the same skies we photograph daily. And yet, because they are nearly transparent, nearly weightless, nearly indistinguishable from vapor, we overlook them. Tonight, as clouds drift silently overhead, consider the possibility that not all motion in the sky is wind-driven. Some shapes may be choosing their direction. Some pulses of light may not be lightning. Some silhouettes may be alive. A living atmosphere? We often imagine Earth's biosphere as something rooted, forests growing from soil, coral reefs anchored to rock, whales swimming through water. But what if life mastered buoyancy? What if evolution reached upward instead of outward? The stratosphere remains one of the least explored frontiers on our planet. Drones rarely linger there. Instruments are optimized for weather, not life detection. Perhaps we have been asking the wrong questions. Instead of searching the stars for alien beings, perhaps we should look at the clouds with new eyes. Because something may already be there. Drifting. Glowing faintly. Feeding on the electrified breath of the planet. Atmospheric jellyfish, ethereal leviathans thriving in a hidden ecosystem far above our heads. And we are only beginning to notice their shadows against the sun. Please like, subscribe and follow for more.